Good day, everyone. In our previous lectures, we have studied the various maneuvers such as takeoff, landing, and hovering. We also studied about how we can turn or rotate the drone in air by manipulating the forces on the rotors. During our discussion, we talked about the stability of the drone. But let us understand what exactly we mean by stability or a stable flight of a drone. Let us look at the term stability in our present lecture. Let's start with defining stability of a drone. How do you define stable is an important part of your question. If you define stable as most engineers would define it as the natural tendency for an aircraft to return to its original state after a disturbance, well, the multi-rotor quad drones are by definition unstable. That is to say that if you disturb the drone, it does not have the natural tendency to return to its original state. Now that engineers have defined your drone as unstable, how is it that when the wind moves, the drone is actually does not return to its original place? Well, the onboard computer is constantly making tiny small adjustments to the controls to maintain the drone in its place. The computer is so good at making adjustments that a drone feels stable, which is probably how you define stability. But if it weren't for your drone's computer making thousands of adjustments each second, your drone would not feel stable. In fact, it would be nearly impossible to fly. A drone is taking due to the following facts are not intrinsically stable, and without electronics, they cannot have a stable flight, which are required, such as high center of gravity, low moment of inertia, and high wind sensitivity. How stable a drone is flying and hovering in the air is related to control electronics, propulsion, dimension, configuration, and sensors. The drone may have the best control electronics, propulsion, and sensor technology and is not yet stable to fly. Think about the glaring errors in a drone if the both propellers are interchanged instead of being arranged diagonally. Such errors are unfortunately already happened, and when the model is tried in hand to start, cause serious injury because the control electronics in this false assembly tries to stabilize the model. For many applications, it is very important to have a maximum stable drone. Imagine a drone on a strongly wobbly drone. The result is not usable if you do not use a good gimbal. One of the sensors that helps in maintaining stability of the drone is the gyroscopic effect. A gyroscope is a device that uses Earth's gravity to help determine orientation. Its design consists of a freely rotating disc called a rotor mounted onto a spinning axis in the center of a large and more stable wheel. As the axis turns, the rotor remains stationary to indicate the central gravitational pull and thus which way is down. One typical type of gyroscope is made by suspending a relatively massive rotor inside three rings called gimbal. According to the study carried by Georgia State University, mounting each on these rotors on high quality bearing surfaces ensures that very little torque can be exerted on the inside motor. Gyroscopes were first invented and named in the 19th century by French physicist Jean Bernard Léon Foucault. It wasn't until 1908 that German inventor Andreas Camphe developed the first workable gyrocompass, according to Encyclopedia Britannica. It was created to be used in a submersible. Then, in 1909, it was used to create the first autopilot. The gyroscope maintains its level of effectiveness by being able to measure the rate of rotation around a particular axis. When gauging the rate of rotation around the roll axis of an aircraft, it identifies an actual value until the object stabilizes out. Using the key principles of angular momentum, gyroscope helps indicate orientation. In comparison, the accelerometer measures linear acceleration based on vibration. A gyroscope would be used in an aircraft to help in indicating the rate of rotation around the aircraft roll axis. As an aircraft rolls, gyroscope will measure non-zero values until the platform levels out, whereupon it would read a zero value to indicate the direction of down. The best example of reading a gyroscope is that of the altitude indicator of typical aircrafts. It is represented by a circular display with the screen divided in half, the top half being blue in color and indicates sky, and the bottom being red to indicate ground. As an aircraft banks for a turn, the orientation of the display will shift with the bank to account for the actual direction of the ground. For a drone to perfectly fly, the IMU, gyro stabilization, and flight control technology is essential. Drones today use 3-axis and 6-axis gyro stabilization technology to provide navigational information to the flight controller, which makes drone easier and safer to fly. Gyro stabilization technology is one of the most important components, allowing the drone to fly super smooth even in strong winds and gusts. This smooth slide capabilities allows us to fly fantastic aerial views of our beautiful planet. With exceptional flight stabilization, along with the waypoint navigation, allow drones to produce top quality 3D photogrammetry maps and radar imagery. The latest drones use integrated gimbals, which also include inbuilt gyro stabilization technology, giving the onboard camera or sensor a particular vibration-free movement. The main function of the gyroscope technology is to improve the drone's flight capabilities. The drone's hardware, software, and algorithms work together to improve all the aspects of flight, including hovering, staying perfectly still, or taking steep angled turns. A drone with 6-axis gimbal feeds information to the IMU and flight controller to vastly improve the flight capabilities. The gyroscope needs to work almost instantly with the forces moving against the drone. This gravity, wind, keep it stabilized. Gyroscope provides essential navigational information to the central flight control systems. In the vast majority of drones, the gyroscope is encompassed or integrated with the IMU. The drone IMU, along with satellite positioning, are also components of the flight controller system. To summarize the lecture, we learned about what exactly the stability of the drone and how it is maintained using the onboard gyroscopic sensors. We also studied how the drone stability is maintained using the gyroscopic effects. In the next lecture, we look at another concept, which is the endurance of a drone. Thank you very much.